In the last example, we talked about using substitution for a nonlinear system. Here's an application of that. This is going to be representative of a nonlinear system where we have to make up the formulas from what we know in geometry. So it says here to find the dimensions of a rectangle with a perimeter of 200 and an area of 500 meters squared. So before we do those numbers in particular, let's remember what it means to have the area and the perimeter of a rectangle. So if we think about the sides as being base and height, what we get for our formulas is, well, for area, it's going to be base times height. For perimeter, we've got two h's, two b's, and so for perimeter, we're going to have the formula 2b plus 2h. So that's kind of our basis in this one. We're going to make the specific formulas out of that with our 200 and our 500 meters squared. So the area is 500 meters squared, so that's going to be b times h equals 500. And then for our perimeter, we're going to have 2b plus 2h equals 200, because 200 is what's specified as our perimeter in our area there. All right, so there's our system of equations. Again, what I recommend is that we try to solve for one that is kind of ready-made right off the bat. I think it's easier to solve in the linear one. It's going to make it less complicated overall. So let's take this 2b plus 2h and solve it for, you can pick one. I'm going to pick h in this case, which would mean that I'd have 2h equals 200 minus 2b. I'm just subtracting the 2b over there. And then I divide by 2 on both sides, and so h is going to be equal to 100 minus b. I'm going to take that now and I'm going to plug that into my other equation up here, the b times h. So I'm going to take that 100 minus b, replace h. I'll just bring this one down here, get a little bit more room for it. So that will be b times, now h we're replacing with 100 minus b, and setting that equal to 500. Now we got to solve, and if you solve, we can distribute that b, giving us 100b minus b squared equals 500. Now, as we can see, we're dealing with b squared, and so we're going to have something to do with a quadratic equation again. With a quadratic equation, we like to get it all on one side. So because I don't like to have a negative on the squared term, I'm going to move it over to the opposite side. So I'm going to dump everything onto the right-hand side, leaving this side with 0, positive b squared over here, minus 100b, because I subtracted that one, and then the plus 500 is still sitting there. All right, so we've got our quadratic. Now this one, unfortunately, is not going to be one that we can factor. It just doesn't work. So when all else fails, we can go to the quadratic formula. So b equals, and we've got negative b, which in this case is negative 100, plus minus square root of b squared minus 4 times a times c. Just barely fitting it in there. All of this over 2 times a. Once we get all that cranked through, you can simplify, let your calculator do the work a little bit for you. B is going to be approximately 94.72 as well as 5.27. So we got to plug those in and see which one makes the base, which one makes the height, and see what we're dealing with here. So if I have 94.72 and I plug that into one of my originals right up here, if I plug that in here and I do 500 divided by 94.72, and just to solve this equation, then what comes out actually is 5.27. And vice versa, if I put 5.27 in there and solve for the other variable, it gets 94.72. So these are the only two possible dimensions that I could have for B or H. So they're just kind of, they go hand in hand. These are the ones that we're looking for. So what we can say then, knowing that is our garden, is going to be 94.72 meters by 5.27 meters. It doesn't really matter what order they're in or which variable they represent, because it's just one or the other, no matter what you do in this case.